So in this video, we will talk about geometric series. So this is a really big topic in this chapter. We will do a lot of different types of examples, and then they will kind of be building up on series. And then you'll kind of see a little bit of applications on where series and convergence and divergence go hand in hand, and what places they actually are used. So to kind of first start off with a series, let's start off with like a decimal. So 0.3333. So you know that this can be repeated. So basically this is kind of like 1/3. One thing that you can do is that you can actually write this as different fractions, kind of like 3/10 plus 3/100 plus 3/1000, and so on and so forth. Because you know that this guy is just going to be 0.3. This guy is going to be 0.03. This guy is going to be 0.003, and so on and so forth. Because if you were to add all these guys, you can see that you're going to get this infinite 0.333333. Okay? So I can rewrite this repeating decimal as a series, because this is basically what a series is. So a finite series, okay, so this guy is just a sum of numbers in a particular order. Okay, so you just have a whole bunch of sum of numbers and they have some sort of ordering. So one example can be like 1 plus 3 plus 5 plus 7 plus 9, so you kind of have a sum of different numbers. Each of these numbers we're going to call terms. So for example, this guy is the first term. This guy is the second term. Okay, and so on and so forth. And basically this entire sum is what we call a series. And then for right now, we'll just write it the long way, and then we'll kind of have a little shorthand notation. So we have this kind of series. Now, we have different types of series and sequences. Sequences are just numbers without the plus sign. But we have different ways to kind of, or different types of series. And the one that we're really going to focus on is a geometric series. And some of you guys have seen this from algebra, and if you didn't, then it's fine. You'll see what they are here. And basically a geometric series, let me give you an example of a geometric series. So for 2, 4, 8, 16, okay? And maybe this one also. 1, -1, 1/4, -1/8. So these two are examples of geometric series. Now the reason why they're called geometric is because you can see that there is a multiple that's being multiplied for every term. So in order for me to get a 2 to 4, I have to multiply by a number of 2, by a factor of 2. In order for me to get a 4 to 8, I multiply by 2. If I get from 8 to 16, I gotta multiply by 2 again. So in this case, this guy is gonna be a multiplication of 2. And if we look at our second example, you can kind of see that for me to get from there to there, I got to multiply by a factor of -1/2. Go to here from here, I got to multiply by -1/2. And I go to here, and I multiply by another -1/2. So here is a multiplication of -1/2. Okay, so here the key word is multiplication. So you're multiplying some sort of number to each term. Okay, so basically, let me give you the definition. So a finite geometric series is a finite series in which each successive term is obtained from the previous by multiplying by a fixed number. and this is R. And this R is what we call the common ratio. Okay, so we have a common number that we're multiplying it each term by. So if you kind of think about what R is in this case, for the first example, R is equal to 2. That's my common ratio. And if you think on the second one, R is equal to -1/2. So this is a common ratio. Okay, so a way that you can kind of think about the common ratio to kind of figure it out is what I like to do is I like to divide the second term by the first term. So basically the second term, and if I divide it by the first term, that will give me the common ratio. Now the one thing that you have to be careful with is make sure that that number is multiplied through every single term. Okay? So usually geometric series kind of look like this. So they have the form a plus, then I multiply it by r, then I multiply it by r again, so I get r squared, then ar cubed, oops, that should be a cubed, then ar to the fourth, and I continue on until I get to the last term. And actually it's n minus 1, because you can see that this is the first term, this is the first, this is the second, this is the third, this is the fourth. So you can kind of see that the number in which you are in the term, and if you try to match it up with the exponent, okay, so look at the exponent here, the exponent here, the exponent here, you can see that the exponent is one less than the term, okay? So that means this guy right here, this is going to be the nth term. Okay, and always for geometric, you have one less. Okay, so that's going to be really important. So here, A is going to represent the first term. R represents the common ratio. And N, ratio. And then N represents the number of terms. Okay, so now let's do a couple of examples to kind of see, see what kind of geometric sequences look like. Okay, so let's say for each series below, determine if it is geometric. Okay, if it is, find A, R, and the number of terms. Okay, so here's my first problem. Let's say we have 1 minus pi plus pi squared minus pi cubed plus pi to the fourth minus pi to the fifth. Okay. So the first thing that we want to do is see if this is geometric. So let's try to find the common ratio R. So remember what I like to do is I like to take A2 and divide it by A1. So in this case, if you see A2, which is the second term, this is the second term. So don't forget about this negative. You can see an alternating sign. So the first one is negative pi divided by A1, which is the first term. And the first term in this case is going to be 1. So that means that the common ratio could potentially be negative pi. So now let's check. So if this is really geometric, I have to make sure that every term is being multiplied by negative pi. So if I multiply this by negative pi, I do get negative pi. Multiply this by a negative pi, I'm going to get a positive pi squared. Good. Multiply this by a negative pi, I get a negative, and then I get a pi cubed. So you can kind of see that you actually get a geometric sequence on series. So this is going to be geometric. Okay, so it's correct. It is geometric. Now I found what R is. Now we got to figure out what A is. A in this case is the first term. In this case, the first term is just 1. And now we got to find the number of terms n. So how many terms do we have? Well, one way that you can do it is just count the terms. 1, 2, 3, 4, 5, 6. Okay, so that's 6 terms. Another way to do it is because we know that this guy is going to be 1 less, then the term is going to be 1 more, which is going to be 6. So you can kind of think about, look at this power, it's always going to be 1 more, okay, than whatever that is. Okay, so now let's look at another problem. So let's say we have 0.01 plus 0.02 plus 0.03 plus 0.04. Okay. So the first thing that you want to do is let's try to figure out what the common ratio is. So let's take R is equal to A2 over A1. A2 in this case is just going to be a positive 0.02, and then A1 is going to be a 0.01. Okay. Writing this gives me 2. Okay, so that means if I multiply each term by 2, I should get a geometric series. So if I multiply this by 2, I definitely get 0.02. If I multiply this by 2, I don't get 0.03. So that means this is not geometric. Okay, so I don't even need to find N and A because this is not geometric, it's something else. Okay, and now let's do one more. Let's say we have 2 plus 2 over 10 plus 2 over 10 squared plus 2 over 10 cubed plus all the way to 2 over 10 to the 8th power. So again, let's go ahead and see if we can find the value of R. So let's just take the second term and divide it by the first term. So it's going to be 2 over 10 divided by 2. So you can put this in your calculator and you'll see that you get 1 over 10. Okay, so that means each term I have to multiply by 1 over 10. So if I multiply this by 1 over 10, I do get 2 over 10. Multiply this by 1 over 10, you can see that you get 1 over, you already had a 10 before, you have another 10, so that's 10 squared. Multiplied by 1 over 10, now 10 cubed, and continues on. So you can kind of see that this is going to be geometric. Okay. So it is geometric. Now all we got to figure out is what A is. A is always the first term, which in this case is 2. And then we need to figure out the number of terms. So another way that you can do it, well, we can't count them anymore because you have a gap here. So we can always just look at the last term. The last term is an 8. If I add 1, that gives me an extra term. Okay, it's going to be 9. So you have 9 terms here. Okay. Okay, so this is how you kind of identify some geometric series.